All right, my lovely children, welcome to math. Today we are jumping into a new chapter all about linear functions and identifying linear functions, solving linear functions, knowing all things about linear functions. And today we are going to start with the understanding of what is a linear function. Let's identify them. Let's talk about how we see them. We're going to talk about them in graphs and in ordered pairs and in equations. So we're going to talk about these three things and how to identify if any of these things create a linear function. Now you might be asking yourself, what the heck is a linear function? And I'll say that's a great question. We haven't talked about this. Really, I might have said this word before. We haven't talked about a linear function. So a linear function this is a function whose graph is made up by a straight line. It's a function whose graph is made up by a straight line. So this is going to lead us right into our first topic here, which is graphs. So the very easiest thing we can do when we're talking about linear functions is to be able to identify them based upon a graph. So if a graph has a straight line, this would be a linear function. Right here, anything that's a straight line is going to be a linear function. Something like this would be a linear function. Something like this would be a linear function. Something like this going straight up and down, linear function. Side to side, linear function. All of these are linear functions. So that is how we can tell that. If we have a graph that looks something like, we've talked about these graphs before. Let's go with like a nice light blue color. We've talked about like these graphs. Is this a straight line? No, this is not linear. This is a function, but it is not a linear function. Okay? Let's say we have something like, we've seen these ones before. There we go, here, and then back up here. This is not linear, same thing. It's multiple, it is straight lines, but it's multiple straight lines. It used to be one solid straight line. Same with this, not a linear function. And even if we were to like have something like this, not a linear function. Linear functions, to visualize them on graphs, they have to be straight lines. All right. Look at that. Already done with graphs. Wow, we are just flying through this. Wish we could talk about linear functions all day long, but I know you probably have more important things to do, and identifying linear functions is maybe not the most important thing. All right, let's talk about ordered pairs. Let's say I have a list of ordered pairs. 2, 4, 5, 3, 8, 2, and 11, 1. Okay, here's a list of ordered pairs. And I say, all right, will this create a linear function? The way we check that is we put these ordered pairs into a table. All right, we make a table with our x and our y's. All right, we go 2, 5, 8, 11, 4, 3, 2, 1. So how we check is we look, all right, getting from one to the other, am I going to do the same thing? How do I get from 2 to 5? I add 3. 5 to 8, I add 3. 8 to 11, I add 3. I'm adding 3 the whole way on my x's. And am I doing the same thing? It doesn't have to be the same thing I did with my x's, but are my y's all changing by the same rate? 4 to 3, I'm minus 1, minus 1, minus 1. Yes, this would be a linear function. If I wanted to take this one step further, I would add 3 to get 14, minus 1 to get 0. And I could put another pair in here at 14, 0. Okay, so as long as my change in my x is doing the same thing, as long as my x is all changing in the same way and my y is all changing in the same way, this is going to be a linear function. Since everything's changing in the same way, linear function. If things weren't changing in the same way, it would not be a linear function. Okay, as long as all my x's change the same way, all my y's change the same way, then things can be linear. Let's see what that looks like when it's not linear. So spoiler alert, this won't be linear, but here we go. Let's go -10. Oh, still on highlighter. Let's get rid of all of this. Get rid of those and get rid of those. All right. Let's say I have -10, 10, -5, 4, 0, 2, 5, 0. -10 to 5, I add 5. Add 5, add 5. 10, I got to do -6 to 4. This is a -2. This is a -2. These right here, these are all good, all the same. Over here, I have a problem. These are not the same. So since they're not the same, it makes it non-linear. This is a non-linear function when things are not the same. All right. Ordered pairs. Let's check that box, call it good. And then finally, the last thing we're going to see is dealing with equations and able to identify a linear equation. And so a linear equation is any equation that can be written in standard form. Okay, so linear equation is any equation that can be written in standard form. And then again, you might be going, well, what is standard form? I get the words, all of these words here, but what is standard form? Well, standard form is a way that we can write equations. So standard form is the way we write standard form. It is ax plus by equals c. ax plus by equals c. So we're going to spend most of our time here today talking about standard form, what this looks like, how we use it. Just looking ahead, when we talk about linear equations, we're going to be dealing with basically three or four forms. One of them is going to be standard form. Then we'll have slope-intercept form. Then we have point form, slope point form. And yes, point slope form is going to be the other one. So we have standard form, slope intercept form, and then point slope form. And all of those deal with linear equations. Standard form is the most basic one of them all. And so we're going to spend the most time on standard form. All right, back to this. So standard form, we're dealing with A, B, and C. And so we need to know some things. These are all A, B, and C must be real numbers. And A and B are both cannot be 0. Okay, so standard form has some rules to it. It's ax plus by equals c. All of my a, b, and c's, those are the variables. Those are changing every time. I don't care what they are. They can be whatever they want, but they're changing. They must be real numbers, and both a and b cannot be 0. All right, so if I wrote this, a way we might see standard form, we might see it written like 3x plus 2y equals 10. If it is written in this form right here, where it's something x plus something y equals something else, this is standard form. This is linear. So this is going to be, it's not going to always be given to you in standard form. It might be given to you in a different form. It might be given to you all jumbled up. But this is going to be where we use that fun lesson that we all loved, where we reorganized all of our equations, to try and get it into standard form. So if I had something like, I don't know, let's say I had something like y equals x plus 3. Can I do something here to put it in ax plus by equals c? Can I get this where my x and y are on one side and my other value is all alone on the other side? Well, let's check and see. I want to get my x over here, so I'm going to minus x and then have minus x. So this is going to give me y minus x equals 3. Y minus x is the same thing as y plus negative x. And now that I have a positive, I can flip my order and have negative x plus y equals 3. And remember, when I don't have values here, this is negative 1x plus negative 1y. This is ax plus by equals c. This is linear, all right? And this might be really, really confusing right now because, again, you don't get to ask questions. We don't get to do a ton of these, but we're going to talk about it a lot more in class, and you will be able to understand these more. But right now, this is just a quick showing of how to find linear. All right, what if I had something like let's say I have y equals 4x minus 3 divided by 2. Is this linear? Well, let's find out. We're going to times 2 times 2. That gives me 2y equals 4x minus 3. Going to minus 4x minus 4x. This gives me 2y minus 4x equals negative 3. This is the same thing as plus a negative, which means I can do negative 4x plus 2y equals negative 3. This works. Ax plus by equals c. What if I had something like x plus 6 over y equals 12. Is this in ax plus by equals c? No, this is not linear. This right here is not linear. I can't have division in my ax plus by. That does not work. It changes how my whole problem will go. Not going to fly. What if I had y equals 2x squared? Well, I would say minus 2x squared minus 2x squared. This gives me negative 2x squared plus y equals 0. This, I skipped some steps to get it to this point, following the steps we did over here. So if you were confused by that, that's where I just made it into plus and negative and then switched it. You just didn't see that happening. And then 0 comes from, I had some things over here, I got rid of them all, so I have nothing left over here. That's where that 0 comes from. So if you're confused, there we go. This is not linear. You can't have a little square in standard form. The squares don't work in standard form. This would be non-linear. All right, before we go, I want you to check 3 different things for me. We're going to have this graph is this linear. Is the graph linear? Is this set of ordered pairs linear? Eight, 3, 12, 6, and 16, 9. Is this linear? Are these ordered pairs linear? And then finally, is this equation linear? All right, 3 things to see. We'll talk about this some more tomorrow. Best of luck. Have a great night.